Hi everyone, in this video I just would like to show you how to calculate if your condition inside a building or the condition that you have measured during a field experiment or the condition of that coming out from a simulation comply with the adaptive EN standard. Okay, so this you can do it in Python using the Python package called pythermalcomfort, which is freely available, so you can download it from PyPy and you can install it on your machine. So there are a lot of other models that you can use, the PMV PPD, the adaptive array, which I've already created a video about, and I would recommend you to check that one out if you're interested. Otherwise, you can calculate the adaptive thermal comfort in comply if check if your condition comply with the adaptive EN. Okay. So if you go to the official documentation of the Python thermal comfort package, you can find more information, which is actually here in front of me. So let me zoom a little bit so you can actually probably see better. So yeah, we just want to check if if your condition comply with the adaptive thermal comfort based on the EN standard, which is 16798-1 2019. Okay. So we will have to provide four input parameters are required in this model, and we will have to calculate and we will have to provide them all. So the first one is the dry bulb air temperature. Pretty simple. It's the temperature that you're measuring from like at a normal temperature sensor. Then you have to provide a mean radiant temperature, which I hope you all are familiar about what it is exactly. Basically, you don't measure usually the mean radiant temperature directly, but you usually measure the globe temperature, and then with the air velocity and dry bulb air temperature, you calculate the mean radiant temperature, and then you need to input the running mean temperature, which is a float, and in order to calculate the running mean temperature, I've created a function which you can find it here in the psychrometric functions. So if you go down here, there is a function which explains how to calculate the running mean temperature, and there is a bit of explanation. Basically, is a temperature that is influenced. So is today's temperature, and is a value for the whole day of today, but is based on the previous 7 days or more of the mean daily temperature. So in order to calculate the running mean outdoor temperature for today, we need to look back at the past 7 days or more and calculate that value, because the adaptive model suggests that our expectation for today, our comfort range for today, the temperature we will perceive as comfortable today, is a function of the temperature that of the previous 7 days, or occasionally they also say that if you don't have that value, you can use the mean monthly temperature. But I wouldn't recommend to do that. I think in these days it's quite simple to get to download the weather data from online sources. So I would suggest you to get the mean daily temperature of the previous day and then use this function here to calculate the running mean outdoor temperature, which later, if you stick and if you keep watching the video, I will show you how to calculate this value. Okay. So in order to have and the results that these let's go back to the adaptive EN. So this function will return a lot of values, as you can see over here, which could be a bit overwhelming if you look at it for the first time. Therefore, for this reason, I actually would like to show you the CB thermal comfort tool, which is also a great tool to visualize the results. So the pythermal comfort is mostly to perform calculation in Python. So if you need to do a lot of calculation, this is probably not very handy with the CB thermal comfort tool. But the CB thermal comfort tool is a great tool to visualize the data. So if you've never seen this tool before, I would suggest you to just check this web page, which is you can access at comfort.cp.berkeley.edu/en. Otherwise, you can click here in the navigation bar. So once you enter this page, you will be redirected. By default, you land on this page, which calculates the PMV PPD in compliance with the EN or the ISO. So if you click this drop-down list here, you go adaptive method. Okay, and you get this nice chart. So we will calculate it with the pythermal comfort. We will visualize it here on the left side to explain what are these values. Okay, So basically the comfort temperature is the center temperature here. So in this case, if you are in this condition, so the outdoor mean running temperature is 24 degrees and the air temperature inside is 25 and 25, we can use the operative temperature, so let's say 25 degrees. We can see that the comfort temperature will be somewhere here in the middle, which will be probably around 26.5. We'll calculate that. And this is, we have the three classes. So the EN standard says that there are three classes of compliance, of acceptability limit. So the one which is the narrower, which is class 1, is the narrower, but you will have most likely the great majority or the higher majority of people which are going to be comfortable. And then if you move to class 2, there are going to be less people who are going to be comfortable with the environmental condition, and then you can move to class 3. The EN also specify which type of building you can keep class 3, which type of building you can keep class 2, and so forth. So this is not the focus of this video. Please go and have a look at the EN standard if you want to know more. Okay, so for this example, I'm going to use PyCharm, and so this was the example of the adaptive for the ASHRE. And you will also be able to find all these examples here. So you can go on GitHub, Center for the Built Environment, and then pythermalcomfort, and you will find this example. So we'll upload after this video. I will push these changes to this repository, so you'll be able to find the file here. Okay, so let's go back to PyCharm, and let's get it up here. So let's create a new file in the example, which I will upload later on. Sorry, yeah, here, and we call it calc adaptive EN. Okay. So first thing that you have to do is you will have to install pythermalcomfort if you haven't already done it. I've already done it in my machine. If you don't know how to do it, you just go in the terminal, which you can access either with the Windows key and then type cmd, and you can do pip install pythermalcomfort, but I'm using like I have the inbuilt terminal here, so I can do pip install pythermalcomfort. In my machine is already installed, so we'll say that already satisfied the requirement, but you will say that here will download the package for you and will install it on your machine. Okay, so let's move to the presentation mode. So presentation mode, so the screen is going to be a little bit, the font is going to be a little bit big. Yeah, here we are. So we can do from pythermalcomfort, and then we have to go models, import adaptive EN in this case, and then we get the adaptive EN function. Okay, we press Ctrl P and we get all these prompts, so the value that we need to enter. So temperature dry bulb, if I don't remember wrong, we set it was 25. Mean radiant temperature again was 25 degrees, and T running mean here we say this was 23. So let me just check that I just want to check that the value are the same. I should say the outdoor mean running temperature was 24. Yeah. And then we could even specify, we have to specify the air velocity, but let's say that the air velocity is 0.1 in this case. If you increase the air velocity, I will show you later in the CV thermal comfort tool, the comfort region will extend. So we run the line of code, that's okay, and we are going to print the result. So we call it result equal to adaptive EN. Okay, so we run both line, and then we actually are going to import from prettyprint, because otherwise from prettyprint import prettyprint. Here we are, and then we're going to print the result. So print results. Yeah, here we are. Technically, yes, these are the results. Okay. So here we get the results. So let me move these results here on the left side, and I want to show you the results and compare them with the adaptive here. So we say 25 degrees, and 24 degrees as a running mean outdoor temperature, and 0.1 as the air velocity. So yes, we are in between all the three categories. So comfortable, we are acceptability with category 1, 2, and 3. That's fine. The comfort temperature before we guess was a little bit above 26. In fact, it's 26.7. So again, this is an imaginary line that passes through this area, so it's parallel to these two lines. So we're going to get something like here. In fact, yeah, 26.7. And then we get all the values. So category 1, which is the narrower comfort region. So we get the upper value and the lower value. So 23.7 and 28.7. So we get the same value. Then we get 22.7, 29.7, 21.7, 30.7. Okay. So if you want to, it's not very happy PyCharm at the moment because import this name. Okay, so from pretty print import pretty print, and now I just would like to change the value up here. So let's perform the calculation again. Let's try to visually change it here. So let's change the operative temperature, and let's go here. So we are too cold for category 1 and class 2, but we are still okay with class number 3. Okay, so let's do the same calculation. We're going to change the temperature to 22.5 and same here, 2.5. Let's run the calculation again and print the results. Again, we can see the same results. So acceptability category 1 false and false, and acceptability category 3 is true. Finally, I just want to show you, I'm sure you know already, but if you want to extract one of these values from the dictionary, for instance, we want to know the temperature, the comfort temperature, we just type a result and then we put the key, we pass the key that we want, I misspell it, so we pass the key inside and we're going to get the value, so 26.7. So if you want to get the conf temperature, you can just get it like this, accessing the key of the dictionary. So basically that's more or less it for this video. Another thing that I want to show you is for those of you that don't like to use the SI unit system, we can also specify the units and we can set IP. In this case, again, let's change it here so I get a reference and I can convert it. So 22.5 is actually 72.5, and the running mean temperature is 75. Air velocity, we don't change it, and let's get the results. So pretty print the results, we're going to get the same value as before, so false, false, and true, but now the output will be in IP, so it's going to be Fahrenheit. Last thing that I want to show you is, so if we go back to the project here, we go and calculate adaptive. I just want to show you quickly, if you want to stick around, how to calculate the running mean temperature value. So let's go back to our previous file and presentation mode. So from here, we have to import it. This one is from pythermalcomfort, psychrometrics, import running mean. So just be careful because this time we don't have to import it from models, but we have to import it from psychrometrics, and this is well explained in the documentation here. So as you can see, if I open the documentation, we're not inside comfort models, but we're inside psychrometric functions, and here there is a bit of description, running mean here, so it's explained. So let's have a quick look. So you will have to provide an array which contains the previous 7 days, and this is going to be the mean daily temperature in descending order, so from the newest to the oldest, so from yesterday, the day before, and so forth. So this will be yesterday, the day before, and so forth, and we need to specify the alpha. So the alpha by default is equal to 0.8, but you can change that. So the EN recommends a value of 0.8, while the ASHRAE 55 recommends that you choose a value between 0.9 and 0.6, and depending if you want a slow or a fast response, or it depends how much weight do you want to give to the previous days. Okay, so for instance, in the ASHRAE says that adaptive comfort theory suggests that a slow response running mean alpha could be more appropriate for climates in which such like in the humid in the tropics. Okay, so this is going to change based on your location where you have collected the data. So let's go back to Python. Here we don't want adaptive ASHRAE, we want adaptive EN. So here let's calculate the running mean value. So let's say that I got the data from the weather data, which is the daily mean temperature of the previous 7 days. So right now I'm in Singapore, so the temperature is quite warm. So the temperature for the previous 7 days, this was yesterday, 29. The day before yesterday was 28, and so forth. I'm putting this value, I'm putting a value of 0.9, and I get a running mean temperature. Okay, so in this case, we haven't imported this, so let's import. And let's calculate the running mean temperature, which in this case is going to be 28.8. So this function for us calculate the running mean temperature, and now we can enter the running mean temperature into the adaptive EN, and we can print the results. Okay, so in this case we are not inside the category 1 acceptability with these inputs, but we are inside the category 2 and category 3. So thank you very much for listening. If you like the video, please press the like button at the bottom or subscribe to my channel for more videos like this one. If you want to know more about the pythermalcomfort, visit the official documentation, or you can actually visit the Python thermal comfort. And you can find more videos on my pythermalcomfort. Pythermalcomfort, and you can find more videos on my channel about the pythermalcomfort. Thank you very much, and see you next video.